The following video will describe how to deal with uncertainty. So in this section, we talk a lot about error and the uncertainty of certain calculations that we are regularly taking. In this process, we want to make sure that we understand the difference between random errors and systematic errors. We'll do that. We're also going to calculate absolute and relative error, which is very similar to absolute and relative change, which we discussed in 3A. We're going to discuss the differences between accuracy and precision. That's probably the most important idea of this section, the most important concept for sure. And then lastly, we're going to understand significant digits as well. So the first thing we want to talk about are the different types of measures or types of errors when we're dealing with measurement. There's a random error, which is obviously what it says. It's random. It's completely unpredictable. So there's not really any rhyme or reason to it. We just know that it's off in some way. And so usually when that happens, there's not really any consistency with it. In other words, if I'm trying to measure out perfect 1 pound packages of cheese, I could have some of the packages of cheese that are a little bit less than a pound, and I could have some of the packages that are a little bit more than a pound, right? If I'm just doing it randomly, I'm eyeballing how much I think a pound of cheese looks like, right? Sometimes I could be over that number, and sometimes I could be under that number, depending. That's different than a systematic error. So a systematic error is an error that just impacts all the numbers, and it impacts them all in the same way. So going back to that example I was thinking about, weighing cheese, maybe my scale's broken, and when I put a pound of cheese on the scale, it actually only reads 3/4 of a pound, something like that, right? What's happening there is systematic. It doesn't matter if I put more cheese on there; it's not going to read accurately. In other words, maybe the scale is always off by a certain weight, like it automatically deducts 1/4 pound, or automatically deducts 25% of the weight, or something like that. So it doesn't matter what that weight is, it's always going to be too low, right? And so it's always impacting the number in the same way. And that's more of a systematic error. An error that happens over and over again because of the same fault is a systematic error. And a random error is just an error that happens by chance. So on we go. Again, we just discussed these. The absolute error can be calculated as a mistaken value minus the true value. So we talked about absolute change and relative change before. Now we're discussing it in terms of error. And so the absolute, like I said, when we want to do that, we always take the true value. We always want to take the true value and subtract it from what the value they thought was. And this just gives us the absolute error. And then the relative error, it compares the size of the absolute error to the true value. Okay, so relative error, just like relative change, is always expressed as a percentage. Remember, when we do this calculation right here, mistaken minus true divided by true, this is giving us a decimal. And so I'm actually going to throw on here times 100%. Or just maybe just times 100. And then we'll say express as a percent. So without the times 100, it's giving it to you as a decimal. Let's look at example 1. Example 1 says, the true price of an item you purchased is $18.98. You were billed $19.98. Find the absolute and relative errors. And in these problems, make sure that you're always keeping an eye on the level of decimal place we want to go back. In this case, we want to go to the nearest 1/10 of a percent. And so we'll calculate. We want to do the mistaken value minus the true value, all divided by the true value. In this case, that is true value is $18.98, and what you were billed was $19.98. $18.98 all over the true value, $18.98. So we get $1 over $18.98. I get 0.0526 and so on and so forth. And so remember, we want to express this as a percentage. We're going to multiply that by 100. That's going to move the decimal place 2 spaces to the right, and we get 5.26 blah 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 percent. Remember, at the end we want to round this to the nearest tenth, which is 1 decimal place. Because we have a 0.26 here, we'll round this up to 5.3%. You paid 5.3% more than you should have. On we go. So the next and probably most important concept that we're going to talk about in here is accuracy and precision. And so accuracy describes how close a measurement is to the true value. It's like finding the absolute change or the absolute error of something. We want to figure out how close you were to the true value. We want to subtract those differences again. And the smaller that margin of error is, the more accurate a particular value is, or a particular measurement, more accurate a particular measurement is. The closer it is to the true value, the more accurate it is. Then there's the idea of precision. Precision just describes how much detail we have about a measurement. And so the more precise something is mathematically, the more decimal places it contains. The farther back we can go to get an idea of what that measurement is. Let's take a look at this example. It says a person weighs 165.45 pounds. The home scale gives their weight measured to the nearest 1/10 of a pound, and it gives their weight as 165.6 pounds. The scale at the doctor's office gives readings measured to the nearest 0.01 pounds, and it gives their weight as 165.61. So which of these scales is more accurate, and which of these scales is more precise? Let's write down the important information that we know. We know the true value is 165.45. And then we have 2 different scales over here. We have a home scale. The home scale says you weigh 165.6. And the margin for the home scale is 1/10. 1/10 as a decimal is 0.1 pounds. At the doctor's office, we have a value that's 165.61, and the margin here is 0.01. So if we want to calculate which one is more accurate, the first thing that we're going to do is take each one of these values here and subtract them from 165.45. So we'll do 165.6 minus 165.45, and we get a difference of 0.15 pounds. For the doctor, we take 165.61 and from that we subtract 165.45. And here we get 0.16. And so the smaller of these margins of error is the home one. This is the one that is more accurate. For precision, we're going to look at these margins. Remember the home margin is 0.1, and the doctor's office margin is 0.01. The smaller of these values is the one that's more precise. And so the doctor's margin is smaller than the home. And so when we say doctor is more precise. On we go. Example 2 says a person's true height is 64 inches. The tape measure can read to the nearest 16th of an inch. It measures their height as 63 and 9/16 inches. A new laser device given at the doctor's office that gives the readings to the nearest 1/10 of an inch gives the person's height as 65.1 inches. Which tool is more accurate? Which tool is more precise? Give yourself a minute to do this one, and we'll pick up in just a second. Okay, so we wrote down the important information. The true value is 64. We'll first go and calculate accuracy. We'll take this true value, and from it we're going to subtract 63 and 9/16. That's going to give us 7/16 of an inch. As a decimal, 7/16 of an inch. 7, our ABC button. 16. Gives us that in decimal form, and then we'll hit our second and F to D. And that gives it to it in the decimal form. 7/16 of an inch. We can say it's 0.4375. That's how far away from the true value the tape measure is. For the laser measure, we do 64 minus 65.1, we get negative 1.1 inches. The positive and the negative do not matter in here because we're only looking at how far away you are from the true value. It doesn't matter if you're more or if you're less. Many people will use the absolute value symbol here because that gets rid of the negative to kind of figure out which one is more accurate. It's pretty easy to see, though. This one is less than 1 and this one is greater than 1. So it turns out for accuracy, we're looking at the tape measure. Tape measure is more accurate than the laser. For precision, a whole lot nicer. We look at our margins of error. Remember that for the tape measure, the margin of error was 1/16 of an inch, so I got to turn that into a decimal. Again, I'm going to do this up here so you guys can see. I'll go 1 and then hit my ABC and then 16. And then I'm going to hit the F to D button, which I have to hit second first, and then F to D. That's going to turn my 1/16 fraction into a decimal, and I get 0.0625. We can see that the tape measure has a smaller margin of error as well. It has a 0.0625, whereas the margin of error for the laser was 0.01. So because 0.0625 is smaller than 0.01, we can see the tape measure is also more precise. So I'm not feeling this laser measure very much. The last thing we'll talk about is significant digits. It's an important concept, particularly for those who are studying accuracy and precision in the sciences. You guys aren't really studying it in the sciences, so it's not something we're going to get in too much detail with. I did create a handout for you guys to take a look at if you want to know more about significant digits, but you won't be quizzed or tested on this concept. It's just floating around in this section. So significant digits, though, are digits in a measurement that give some insight into the precision of that number. It's really important when we're calculating things that have different significant digits that we abide by the rules of significant digits so that we get the right level of precision. Like I said, not going to be something that you're going to be tested on, so I don't want to go into too much detail with it, but it's very similar to rounding in a sense that we're looking at the totality of the number and telling us how far back we want to go so that we can represent the number in a fair sense. That's pretty much all you need to know about that. Thanks so much.